There's a hole on the moon. From orbit, it looks insignificant, just a dark circle in endless gray dust. But that hole could decide whether humanity survives beyond Earth, because the surface of the moon is deadly. Radiation, extreme temperatures, micrometeorite impacts. So instead of building upward, we're going down. Robots are being designed right now to descend hundreds of meters into ancient lava tunnels, caverns carved by fire billions of years ago. No human has ever seen what's inside. No sunlight reaches the bottom. And what those machines discover in the darkness could become the foundation of the first permanent moon base. Before humans move in, something else must go first. From orbit, it looks like nothing more than a dark circle in the gray dust, an opening in the surface, almost like a wound. But beneath that opening may lie one of humanity's greatest opportunities, a vast underground cavern, shielded from radiation, protected from deadly temperature swings, hidden for billions of years. And soon, robots will descend into it. Before astronauts build the first permanent base on the moon, before habitats inflate and solar panels rise, before humanity calls another world home, machines will go first. They will lower themselves into darkness, into silence, into places no human eye has ever seen. Because the future of lunar civilization may depend on what they find below. From Earth, the moon looks calm, peaceful, serene, beautiful. But step onto its surface, and the illusion disappears. There is no air, no atmosphere to scatter sunlight, no magnetic field to deflect radiation, no protection from solar flares. When the sun rises over the lunar horizon, temperatures soar past 120 degrees Celsius. When darkness falls, they plunge below negative 170. That's a 300-degree swing. Every 2 weeks, the surface is bombarded by micrometeorites, tiny fragments of rock traveling faster than bullets, and cosmic radiation constantly pours in from deep space. For astronauts on short missions, shielding and suits are enough. But for a permanent base, for months, years, generations, the moon's surface becomes a deadly place to live. But found on the moon itself, if humanity is going to stay, we need protection, not built from Earth. Billions of years ago, the moon was not quiet. It was volcanic. Massive lava flows poured across its surface, forming the dark plains we call Maria. As molten rock flowed, the outer layer cooled and hardened, but underneath, lava kept moving. When eruptions ended, the liquid rock drained away, and what remained were tunnels, lava tubes. On Earth, lava tubes stretch for kilometers, like natural subway tunnels carved by fire. But the moon's gravity is only 1/6 of Earth's. That means ceilings can span wider distances without collapsing. Some scientists estimate lunar lava tubes could be hundreds of meters wide, perhaps even more, large enough to house entire city blocks. Protected by meters of solid rock, nature's radiation shield, nature's bunker, and we didn't even have to build it. In 2009, orbiting spacecraft began spotting something unusual: dark pits, circular holes in the lunar surface. They weren't impact craters. They were vertical shafts, openings where the ceiling of a lava tube had collapsed. Skylights, doorways into the underground. Some appear to drop straight down. Others slope into darkness. No sunlight reaches their floors. No human has looked inside. But thermal measurements suggest something extraordinary. Inside these pits, temperatures remain far more stable than on the surface. Instead of 300-degree swings, the underground environment may hover around minus 20 degrees Celsius. Cold, but manageable, predictable, shielded. The moon may already contain the perfect shelter. We just have to reach it. We cannot send astronauts blindly into a vertical shaft hundreds of meters deep. We don't know if the walls are stable. We don't know if loose debris could collapse. We don't know how far the tunnels extend. And once you descend, climbing back out isn't simple. So the first explorers won't breathe oxygen. They won't feel fear. They won't need sunlight. They will be robotic pioneers. Engineers are developing robotic systems capable of rappelling down sheer rock walls, using thrusters to hop across uneven terrain, rolling like spheres through jagged corridors, flying briefly in low gravity using small propulsion bursts, operating in total darkness using LiDAR mapping. Some concepts involve tethered robots that lower themselves into pits, scanning every centimeter of rock. Others envision swarms, dozens of small autonomous explorers mapping the tunnels together, each one acting like a node in a distributed brain, mapping, scanning, analyzing, before a human ever sets foot inside. Once inside, the robots begin their real mission. They deploy LiDAR, laser pulses that bounce off rock walls and create 3D maps. They measure radiation levels. They test rock stability. They analyze mineral composition. Ground-penetrating radar searches for hidden voids. Thermal cameras scan for temperature gradients. Some missions proposed by researchers at organizations like NASA and the European Space Agency include robotic explorers specifically designed for cave environments. Because if we can understand these structures in detail, we can determine whether they are stable enough to host a habitat. And if they are, everything changes. Water is life. On the moon, it is also fuel. Split water into hydrogen and oxygen, and you have rocket propellant, drinkable water, breathable air. Some lunar regions near the poles contain frozen water in permanently shadowed craters. But what about lava tubes? Shielded from sunlight for billions of years, they may preserve volatile compounds, including ice. If robots detect water inside these caverns, it would dramatically reduce the need to launch supplies from Earth. Every kilogram launched from Earth costs enormous energy and money. Local resources make long-term settlement possible. Sustainable. Real. Imagine the next phase. Robots confirm structural stability. Radiation levels are low. The cavern is vast. Now the builders arrive. Autonomous construction units begin 3D printing structural reinforcements using lunar regolith. Inflatable habitats are delivered and expanded inside the tube. Surface solar arrays beam power down through cables. Life support systems activate. Air fills the interior modules. Lights illuminate rock walls untouched for billions of years. And for the first time in history, humans live beneath the moon's surface, protected by meters of solid basalt, safe from radiation, safe from micrometeorites. In a natural fortress carved by ancient lava, this is not just about the moon. Mars also has lava tubes, even larger ones. If robotic cave exploration succeeds on the moon, the same technologies can prepare Martian habitats. Before humans establish settlements on another planet, robots will descend first. Mapping, testing, preparing. The moon becomes our proving ground, our training site, our first off-world neighborhood. For all of human history, we have built upward. Cathedrals, skyscrapers, towers that reach the sky. But our first city beyond Earth may begin underground, not beneath blue skies, but beneath gray regolith, in silence, in darkness, lit by artificial suns. And when future generations look back at the beginning of humanity's expansion into space, they may not remember the first astronaut who moved in. They may remember the first robot that descended into a hole in the moon and prove that we could survive there. The next chapter of civilization may begin beneath the surface,